start by asking a research question. What do you want to know? State your hypothesis. What do you think will happen? Explain your experiment. What data are you collecting, and what's your control? Analyze your results. What observations did you make? Make a conclusion. What did you learn? And do you have any more questions?
By Heart Program. Episode 1, Plotting Data in U. That is when normality matters.
Hi Stata.
Hi Amanda.
Today we are starting our new program, Stata by Heart.
Alright, and I'm so excited that I'm finally gonna learn statistics and I'm putting X amounts of heartbeats on it.
Absolutely, Stata. So today we are starting our educational program to strengthen the basis in statistics. Let's start with quiz time. This is our quick answer for quick Stata questions. Do you know what statistics means, Sarah?
Yes, Amanda. I have learned during this week that statistics is the collection and interpretation of data. For example, in research, there are some important definitions here. A population is a total amount of set or collection under investigation. A sample is a subset of population, and a sample size is a total amount of the sample.
So let me try to illustrate what you already have mentioned, Sarah. Let's consider all of these people that are getting the screen as a representation of a population. So when we randomly select some subjects of this population, we create a subset of the population, which means the sample of the population. So let's imagine that randomly this one was chosen and also this other one. And now we have the sample of this population. So, Sarah, a population is often denoted with uppercase N, while the sample with lowercase n. For the population, the number that describes the whole population is called parameter, and the number that describes a sample is called statistics. A representative sample is the sample that accurately reflects the population. What is data, Sarah?
Well, data item is usually called a variable, and a variable contains data about anything we count, measure, or observe. And we use statistics to measure and analyze variables. Tell me the type of data do we have, Amanda?
Well, we have qualitative and quantitative variables. Qualitative or categorical variables are classified in nominal and ordinal. However, quantitative variables are divided into discrete and continuous. Let's go upstairs, Sarah, to talk more about it.
Okay.
Statisticians want to perform statistical analysis, they have to know what the data looks like. One of the most important aspects is the classification of the data into quantitative and qualitative, as well as the type of scale level that each variable has, nominal, ordinal, or metric. In today's video, we will explain what the difference between qualitative and quantitative data is and how to distinguish between the scale levels. When dealing with data, a common question is what kind of variable are we dealing with, quantitative or qualitative? Quantitative variables consist of measurable or countable features, such as time of survival, number of blood cells, blood pressure, age, or number of children in a family. Qualitative variables, in contrast, are not measurable and presented as scales of text, such as the blood group, gender, satisfaction of a patient on their treatment, status of a disease, or status of survival. Quantitative variables are all in the scale of metric variables. We distinguish between discrete and continuous data here. Discrete are all counting variables that have only integers, such as number of children in a family. Continuous variables, on the other hand, can assume all values, including decimal numbers like size or weight of a person. All metric variables have a scale, and therewith a sequence by definition. Differences are therefore interpretable. Qualitative variables, in contrast to metrically scaled quantitative variables, are distinguished in nominal and ordinal scaled variables. Nominal variables contain data in classes, such as the blood group, that does not have a qualitative order. Therefore, they have no sequence, and distances between two classes are not interpretable since they have no qualitative meaning. Ordinal variables, on the other hand, as the name already says, have an order in their occurring classes, for example, measuring intensity, agreement, or satisfaction from strong towards little. Distances between two classes are interpretable, but may not be comparable. So nominal variables are simply determining a certain status, whereas ordinal variables can be sorted and ordered.
Let me open this door so we can get inside, Sarah.
Yes, just step there.
All right, let's go. It's much better now, don't you think?
Yes, for sure.
So, Sarah, why is normal data so special?
For so many reasons, Amanda. A normally distributed data is symmetric about the mean, has equal measures of central tendency, follows an empirical rule, aka 68, 95, 99.7 rule, and most statistical tests require assumptions of normality, for example, parametric tools.
And let's now take a look in the central limit theorem.
Okay.
The central limit theorem shows that the average of values drawn from the distribution will always be approximately normal. Furthermore, the bigger the sample size, the narrower the distribution of average becomes, and the closer the mean of the sample gets to the true mean of the population. This is why sample size matters so much in any statistical analysis, whether it is a political poll or evaluation of a medical procedure. There is something very special about the normal distribution. Not only do many things we measure in biology follow a normal distribution, but it also crops up when we look at estimates of variables even when the variables themselves don't have a normal distribution. Because of this, we can use the normal distribution to test ideas about the world even when the underlying variables don't follow a normal distribution.
Your turn now, Sarah.
Well, what are descriptive statistics, Amanda?
In clinical trials, descriptive statistics such as measures of central tendency are very useful by providing a single number that describes the middle of a data set. So, the mean, the median, and the mode are the most common measures of central tendency.
Oh, median versus mean. Now we are literally stuck in the middle.
Oh yes, very good indeed, Sarah. Let's take a look in this example, which reflects the distribution of high for all these personalities in the sample. So the highs are already in ascending order of magnitude, as you can see. If you want to calculate the mean, you need to sum each high of all of them and divide the result by the total number of these personalities. We have 1, 2, 3, 4, 5. the sample size, and we have all of this height, and the total is, as we see in the screen, and this is the result of the mean. To find the mode, we select the value that appear the most often. For instance, in the sample, the high of both sharps was repeated 2 times, so their high is our mode here. Finally, to describe the median high for the sample, we need to put the values in ascending order of magnitude, as you can see. Thus, middlemost high value is the high of the tourist personality. That is our median here.
As we could see, Amanda, the data distribution plays a role in making a decision on setting the most adequate measure of central tendency to a data set. So, when data is symmetric or normally distributed, the median and the mean represent the same value. In this situation, mean is easy to access and therefore it is more used. On the other hand, mean and median can be completely different in a non-normal data. That's why the researcher often reports median instead of mean, since outliers do not affect the median.
Measure of center. An outlier is when one data value is much greater or much less than the rest of the data values in the set. An outlier may affect a measure of center. Determine how the outlier affects the median and the mean in the following quiz scores: 55, 88, 90, 93, 94. Let's first identify the outlier. Yes, it's 55. Next, let's find the median. Now let's determine how the outlier affects the median by finding the median without the outlier including. The median without the outlier is as follows. Did the median change? Yes. By how much? 1.5. Next, let's calculate the mean of these same data set. Let's determine how the outlier affects the mean by finding the mean without the outlier included. Did the mean change? Yes. By how much? 7.25. Which measure of center changed more with the outlier? The mean. A rule of thumb: when there is an outlier, it is best to use the median. When there is not an outlier, use the mean when finding the measure of center or comparing the measure of center.
Very essential to acknowledge, Stata, that descriptive statistics are used to simplify and summarize data. Graphics and tables also help us to represent data and explain descriptive statistics. However, measures of central tendency are often not enough to summarize a dataset. That's why measures of dispersion, another descriptive measure, are combined to median and mean in order to also describe the spread of the data. As a consequence, a dataset is more coherent when data distribution has less variability.
The standard deviation and interquartile are two common metrics of spread. Since interquartile range mainly uses the 25th percentile and 75th percentile values of the dataset, there is no impact by outliers. However, the standard deviation complies all values of a dataset so that it is highly affected by an outlier. Thus, we perform interquartile range and standard deviation in non-normal data and normal data, respectively. That's why normality matters.
3, 2, 1.
If you're selling dietary supplements as health-promoting pills, with no conclusive evidence of curing any ill, there's bound to be some poorly run trial from long ago, showing up some small effect that other trials do not show. You can quote this honestly, even though you cherry-picked it, but leaving out the other trials is just lying with statistics. When meeting a statistic, about which you have some doubt, ask yourself, whose claim is this, and how do they work it out? Is there some crucial fact they've chosen to leave out? Has the subject changed between the stats and what the claim's about? Always check the detail and how interests try to twist it, because using numbers without context is just lying with statistics.
Oh, Sarah, we are coming to the end.
I just loved our Stata by heart, Amanda.
And I'm so happy we are involved in this video program, Sarah.
Absolutely, Amanda. And it perfectly fits the quote. Tell me and I will forget. Show me and I might remember. But involve me and I will understand.
Wonderful.
If you're feeling distressed cause your data's a mess and you're going as mad as a hatter, cause you really want P to reflect reality, that's when normality matters. When you've been up for days in a statistical haze, you're tired and emotionally shattered. You don't want to be fooled by your confidence intervals, that's when normality matters. If your life has got skew and you're wondering what to do cause you feel like your brain has been battered, if your sample is small then remember the rule, that's when normality matters. If the scores you collect are distributional wrecks, remember this doesn't matter, cause for CIs and Ps you need normality of the sampling distribution of the parameter.